Hello everyone, my name is Sudeep. Today we are explaining about the semiconductor RAM memories. As you know, the semiconductor RAM memories are available in wide range of speeds, and most of the memories are the semiconductor RAM memories, and their cycle time normally range from 100 nanoseconds to less than 10 nanoseconds. And they were first introduced, they were much more expensive than the magnetic core memories, and now they were completely replaced the magnetic core memories, as most of the memories are implemented by using the based on the semiconductor memories. In this session, we discussed about the characteristics of main characteristics of semiconductor memories. Now let us see the internal organization of memory chips. Here you can see the internal organization of memory chips. You can see that the memory chips cells are normally organized in the form of array. The each cells are having one bit of information, and all cells of a rows are connected in a common line called as a word line. Word line is a connected to the address decoder. The sensor write circuits are connected to the data input or output lines of the memory chips. The data input and data output of each sense or write circuits are connected to a single bidirectional data line, and data line can be connected to the data bus of the computer. The following two controls lines are also used: read or write and the CS. The read or write are the specifies the required operation. The CS is the chip select to input given chip in the multi-chip memory. And here you can see the another diagram. It is the organization of 1K by 1 memory chip. The 10-bit address is divided into two groups of each 5 bits and to form a row and column address of the cell memory. A row address is selected at 32 cells, all which are accessed in parallelly, but only one of the cells is connected this external data line based on the column address.
Hello everyone, I am Srinivas. Today we have discussed about the CMOS cells, static memory cells. Static memory cells transfer inverse the cross-connected implement of basic flip-flop. This is the diagram of the static memories. How it works, diagram is how it works. Explain the left side. The cell is connected one word line and two bits line are transferred T1 and T2. You see the diagram T1 and T2 is the transistor lines connected to the word lines. When the word line is ground level, the transistor is turned off and latch returns to the state. Read observation: in the order of read state of SRAM cells, the word line is activated to close the switches to T1 and T2. Sense write circuit at the bottom of the minter state of B and B dash. Whenever T1 T2 is act like the keys, when we are in T1 is open with B1 and B dash is connected to the sense write circuits. Next is CMOS cells. CMOS cells is the full form of a complementary metal oxide semiconductor. CMOS is the combination of the PMOS cells and MOS cells. This is the block diagram of the CMOS cells. How it is connected in explain the left side. The transistor paired T3, T5 and T4, T6 from the inverter in the latch. In the state 1, the voltage of the point X is high, having a T3, T6 on T4, T5 are off. Those T1 and T2 return on or closed. Bit line B and B dash will have a high and low signal respectively. Advantages of the CMOS cells: it is a low power consumption. The current flows the cell only when the cell is active. Another advantage is a static RAM that can be accessed quickly. Its access time is few nanoseconds. What is the disadvantage of the CMOS cells? SRAMs are said to be the volatile memories. They are contain the lot memory power in the interrupted.
Hi everyone, I am Sanjay. I am going to explain the asynchronous memories of dynamic RAM. This less expensive RAM can be implemented is if simple cells are used. Such cells cannot retain their state indefinitely, hence they are called dynamic RAM. The information stored in a dynamic memory cell in the form of a charge on a capacitor. This charge can be maintained only for tenths of milliseconds. The contents must be periodically refreshed by restoring the capacitor charge to its full value. The example of a single transistor dynamic memory. This is the T is connected to the transistor and capacitor. This is the diagram, the example of the asynchronous single transistor dynamic memory. In order to store information in the cell, the transistor T is turned on. The appropriate voltage is applied to the bit line which charges the capacitor. After the transistor is turned off, the capacitor begins to discharge. Hence, the stored the cell retrieved correctly before the threshold value of capacitor drops down. During a read operation, transistor is turned on. Since amplifier detects whether the charge on the capacitor is above the threshold value. If charge on capacitor is greater than value, threshold value is bit line will have logic value 1. If charge on capacitor the threshold value less than threshold value of bit line will be logic value is 0. Next slide will be explained my friend Shashank.
Now, as my friend explains about the asynchronous memory, now I am going to explain about the description of that. See the asynchronous DRAM description. See in this each row and each row can store 512 bits, 12 bits to select a row and 9 bits to select a group in a row. Its total is 21 bits. First apply the row address, that is RAS signal, latch to the row address, and apply the column address CAS signal, latch to the latch address. Then time of the memory until is controlled by a specification unit which generates RAS and CS. This is known as DRAM. See, as you can see in this diagram, the RAS which is connected to the row address latch and CAS connected to the column address latch, and A80 which is connected to row address latch, and 820 to 9 it is connected to the column address. Then these are connected to sense or write circuits, and which is connected to the CS or read or write. Next, it's about the fast page mode. Actually, this means the block of transfer capacity is known as a fast page mode. See, it means the transferring the bytes in sequential order is achieved by applying the consecutive sequence of the columns address under the control of successive CAS signal. Actually, this scheme allows transferring a block of data and the at the faster mode. The block of transferring capacity is actually known as the fast page mode. Thank you.